So today, the next lesson, we're still talking about limits. This whole chapter is about limits, okay? Deals with limits. So now we're talking about limits to infinity. When I say infinity, there's a reason why it's infinity. It deals with vertical asymptotes. So vertical asymptotes, let me show you. You've seen pictures of them if you don't know what they are. Let me see, like right here. So if you look at where x equals 5 up here, it's not on your paper, but if you look at where x equals 5, this guy right here, this dashed line, that's an asymptote. It's vertical because it's going straight up, right? Vertical asymptotes. There's horizontal asymptotes, which we'll talk about next week, but today we're just talking about vertical. Why is this guy there? Because this function does not exist anywhere at 5. Whatever this equation was, they didn't give me this equation, but whatever it was, if I was to plug in a 5, I wouldn't get an answer. I wouldn't get an answer. So if you can't get an answer, what are you supposed to do? Vertical asymptote, okay? Oops. Okay, so that's what a vertical asymptote is. Okay, that's what a vertical asymptote is, wherever functions are defined. So how do we find limits at vertical asymptotes? Well, let's go back to this guy. So let's say I'm trying to find the limit as x approaches 5 from the left here. Well, from the left would be from the less than side, right? So where is it going as it gets closer and closer to x equals 5?
Positive infinity.
Yeah, it's going to positive infinity, right? Up as far as it can go. What if I go the other way? So what if I'm coming from the negative side, or from the positive side? Where is it going?
Positive.
Same place, right? Positive infinity. So it only has two options, either go up or go down. Because you can't go through. You cannot go through vertical asymptotes. Functions cannot go through them. You know, you have two options. You either go up like this guy, or you go down. You hug it and go down. There's no going through them. So limits, when there's a vertical asymptote, are one of two. It's either positive infinity or negative infinity. It's either going to go straight up and never cross, or it's going to go straight down and never cross. That's all. It has two options. Our job is to figure out which one. So on the first side, it's more pre-calc stuff. You might not have had this in Math 3, so I want to go over it. That's why I put the first example 1. Example 2 is more of the calculus stuff. Okay, so example 1 is not, there's nothing about limits there. It's just find the vertical asymptotes. Okay, so note, this occurs whenever there is a value of x that gives you 0 in the denominator. So that's the most popular one. How do I make something undefined? When 0's in the denominator. There's other ways to make undefined, but the most popular one is when 0's in the denominator. Okay? But not in the numerator. So something other than 0 on top. Okay? If the value of x gives you a 0 in both the top or bottom, that represents a whole. That represents, this guy here, or this guy here, or this guy, or this guy. That's why there's holes there, because there was a 0 on top and bottom. Okay? Okay, so here we go. All right, so let's look at A, 1A. Where on 1A is the only place where it could be undefined? Where is the only place we're worried about?
That 2.
Why 2?
Because the bottom would be 2 times 2 minus.
There you go. You just said it. The bottom, right? All we care about with vertical asymptotes is where the bottom equals 0. Right? Where the denominator equals 0. That's where we care about with vertical asymptotes. Denominator, where does the denominator equal 0? So for this guy, I'm not even going to worry about the top. I'm just going to focus on the bottom. I need to figure out where the bottom is going to be 0. And you guys just said it's going to be at 2. It is. How do we know that? Because when I set the bottom equal to 0 and solve, right, add 4 to both sides, 2x equals 4, divide by 2, I figure out that when I plug in 2 to the bottom, I'm going to get 0. I'm going to get 0. When I plug it into the top, you don't get 0. You get 1. Oh, sorry, you get 3. So that's going to be a vertical asymptote. Okay? So we say vertical asymptote, VA, I just use VA for short, at x equals 2. That's the only place because that's the only number I could plug in there. If I plug in -2, it's going to give me -8. It's not going to give me 0. Okay? Let's look at the next one. Vertical asymptote at the next one. Well, if it's a fraction, the only place I'm going to check is at the bottom, when the denominator equals 0. So I'm going to set the denominator equal to 0. X squared minus 4x plus 3 equals 0. Well, this guy has an x squared and an x, so I can't do what I did on the last one, because the last one was linear, right? This one was linear. There was only one x, so I could isolate it. This guy you can't isolate, because it's a trinomial. So you got to do what we did the other day, right? Is there a GCF? No. A is 1, B is -4, C is 3. You got to factor it. So 3 and -4, so I'm looking for the two numbers that multiply to be 3 and add to be -4. -3 and -1. First term always goes up top, last term always goes on the bottom. Then I have -3x and -1x from the x game. Factor x times x, and then -3 and -1. So this guy is going to factor to x minus 3 and x minus 1. Okay? It's going to have two answers because it's a quadratic. Quadratics have two answers. Cubics have 3 answers. Quartics have 4 answers, and so on and so forth. So how do I get my 2 answers? What's the last step I need to do to get my 2 answers? Set both equal to 0. Yep. And you're going to get 2 answers. This part you can probably do in your head. If you can, don't worry about it. In calculus, any like pre-stuff, so this stuff you guys did in math 1, math 2, or math 3, like this stuff right here that we just did factoring, you guys did in math 2 and math 3. That stuff, like I'm not really worried about seeing the work for. I'm more interested in the calculus part. So like some of these steps you can kind of, some of you can skip steps, that's okay. Because this is not calculus stuff. This is pre-calculus stuff, math 2 and math 3, okay? So I get 2 answers. Only one of them works. Only one of them is going to give me a vertical asymptote. Which one's going to give me a vertical asymptote? Oh, wait. Yeah, only one of them is going to give me a vertical asymptote. Not 1. 3. Why 1? Why not 1? What is 1 going to do?
To make undefined or not.
It's gonna put an actual number.
Because it'll be 0 over 0.
It's going to be 0 over 0, right? And 0 over 0, it said are wholes. So it's going to be a whole at 1. So whole at x equals 1, vertical asymptote at x equals 3. Didn't ask me about wholes, but I definitely don't want to put vertical asymptotes at both. Because if I plug in 1 on top, I get 0. If I plug in 1 on bottom, I know I'm going to get 0 because that's why I solved for it. Okay. Okay. All right, so let's look at letter C. Vertical asymptote, bottom. X plus 1 squared equals 0.
Can we just do x plus 1 and then x minus 1?
So we can do x plus 1 and x plus 1 because it's squared, right? So it has to be the same. So you can do x plus 1 and x plus 1. But since we only have one x, right? There's only one x here. What I'm going to do is, what's the opposite of squared?
Square root.
Take the square root of both sides. So we get x plus 1 equals the square root of 0, which is plus or minus 0, but 0 is just 0. And then subtract 1 from both sides. So is x equal -1 a whole or a vertical asymptote? Vertical asymptote, yeah, because you can't plug it into the top. The top is a 1. I can't plug in anything to the top. It's always going to be 1. So if I was to plug in the bottom, if I was to plug in -1 to the bottom, I'd get 0 squared, which is 0. So we say vertical asymptote at x equals -1. You don't have to write this down, but let me give you an example. What if it said, give me the vertical asymptote for x squared plus 3x minus, 10. It said, give me the vertical asymptote for this guy. Kind of a trick question. Why is it a trick question?
Because it's not a fraction.
Because it's not a fraction, right? Is it going to have, what's the bottom of this guy?
1.
Is that ever going to change? No. So you don't even have to check. You would just say no vertical asymptotes, right? No, there's no chance of it having vertical asymptote or a hole, right? Because there has,
0.
what's that?
What if you get 0?
That 0 is a number, so the dot would be at 0. So it'd be at whatever number you plugged in. You can solve it, like if you solve it and did this, right? Set it equal to 0 and did that. Those would be solutions. That would be where it crosses the x-axis. Yeah, but in terms of vertical asymptotes or holes, it wouldn't have any. It's not a rational expression. It's not a fraction. Okay. All right, so now let's go. This side is the calculus side. This is the calculus side. But the reason I put it second was because we had to practice finding vertical asymptotes. Vertical asymptote is called a discontinuity. It's where, there's 3 types of discontinuity. We'll talk about this in a couple weeks, but vertical asymptotes is one. Holes are the other, right? Anything that makes me pick up my pencil. So if I was drawing this, I'd have to pick up my pencil to continue over here, right? That's a discontinuity. And then if I wanted to continue drawing, I'd have to pick up my pencil again, right? And then if I wanted to continue drawing, I have to pick up my pencil.
Wait, so then why is that a hole under the 4 1?
Right here.
Yeah.
So
Pick up the pencil.
I didn't, but I really should have, because there's a hole here. So if there's a hole, I can't have a dot there, so I draw a hole. I didn't do that, but I should have, yeah. Okay, so discontinuities mean anytime you pick up your pencil. So there's 3 types. One of them is a vertical asymptote. One of them is what we call jump, because I had to jump from up here to up here. Right? We'll talk about that in a few weeks, but. Okay, so do these guys look familiar? A, B, C. Oh, there's a D, but do A, B, and C look familiar? Because they were on the other side, right? Okay. So when you're finding the limit, especially when you're finding the limit, you notice how this guy has a negative in front? It's coming from the left, right? So when you're looking at one of these guys from the left or from the right, always first check to see if there's a vertical asymptote anywhere. That's the first thing to check. If there isn't, or let's say there was a vertical asymptote at 1 or something other than 2, don't worry about it. Plug in 2 and you're done. But what's going to happen when I plug into 2? It's going to be it's not going to work, right? So the first thing I need to do is figure out if there's a vertical asymptote. There is a vertical asymptote, right? We know there's a vertical asymptote at x equals 2, right? We know that from 1a. And isn't it asking me for the limit at x equals 2? Okay. So that means it's not going to have a number. That means it's going to be one of these situations that were at the very top. Right? It's either going to be positive infinity or negative infinity. Okay? Since it's this side, it would be either positive infinity or negative. That's going to be my answer. It's either going to be positive infinity or negative infinity. Here's a trick question, or just not a trick question, but another question. What if that negative wasn't there? How would we solve that limit? How do you always solve limits? What's your first step for solving limits always? Before that, plug it in, right? So if we were to plug in 2 for the limit, so I'm talking about this guy was not here. It would not be undefined. You're close. Does not exist. Yeah, it would be does not exist. If that guy wasn't there, it would be does not exist. Because wouldn't we get 3 over 0? The reason we can't do that here is because it is going to have a limit, either at positive infinity or negative infinity. It's going to have from the left side. One-sided limits always have answers. One-sided limits always have answers. Two-sided limits, without those, could be D and E. Okay?
So how would you plug in the 2 minus into there?
Yeah, we're going to do that right now. We're going to do that right now. So let's write this down. One-sided limits always have answers. Never D and E. If you have a one-sided limit, your answer is never going to be D and E. It's always going to have an answer. Now, the answer could be positive infinity or negative infinity, like this one. Or, but it's always going to have it. It's not going to be D and E. D and E's only happen when it's a two-sided limit. Okay, let's see. Are any of these two-sided limits? These are all one-sided, right? Yeah, one-sided. These are all one-sided. Okay. Okay, so how do we solve this? Well, I can't plug in 2, right? You guys just said I can't plug in 2 because it's going to give me 3 over 0. And that's not a number I can use, right? So what do I do? Well, first of all, I only care about the left side. I only care about the left side of the equation. So let me draw a little picture real quick. You don't have to do this, but sometimes it helps just to see. So we want 2, right? 1, 2. We know at 2 it's going to be a vertical asymptote. Right? We know at 2 it's going to be a vertical asymptote. So I can't plug in 2. So what do? Well, I only care about the left side, right? I don't care what's happening on the right side, on the greater than side. So what I'm going to do is I'm going to plug in 2 numbers. It's either going to be going up or it's going to be going down. Positive infinity or negative infinity. So I'm going to plug in 2 numbers on this side, the left side of the blue.
1 and 0?
You could pick, yeah, that's what I was going to pick. 0 and 1 would be perfect, right? Especially since I can't use a calculator. If you could use a calculator, I might say get as close to the line as you can. Always want to try to get as close to the vertical asymptote as you can. So I would say, you know, if I had a calculator, I would plug in like 1.5 and 1.9. But I don't have a calculator. I can't use a calculator on this question. So 0 and 1 will work. That's about as close as I can get. So I'm going to plug in 0 into the equation. See what I get. Zero and 1. So when I plug in 0, what do I get?
Negative 1 over 0.
This is -1, yeah, -1. I plug it in, 0 squared minus 1 over 2 times 0 minus 4, right? So I get -1 over -4, which is 1/4, positive 1/4. So that means that guy's there. At 0, it's there. So it's got two options. It can go straight up or it can go straight down. What's going to tell me that? The next dot. As I get closer, what's happening? Is it going down or is it going up? So the next one I'm going to plug in gets closer, 1. So 1 squared minus 1 over 2 times 1 minus 4. So 1 squared is 0 minus, 1 squared is 1 minus 1 is 0. And then on bottom I get -2. If you have 0 on top, it's always going to be 0. So 1 comma 0. So from left to right, are the red dots going up or are they going down? They're going down. So they're only going to go down from there. So if I was to plug in 1.5, it would be a negative number. So I know for a fact that it's going to go down because it only has two options, go up or go down. It's not going to change its mind. Once it heads in one direction, it's going to stay in that direction. Okay? So the answer to this one, negative infinity. Because of that. So yeah, so how do I plug in that number? You can't. You got to plug in numbers that are close to that. Get as close as you can to it. Okay? All right, let's do B. So now +3 from the right. +3 from the greater than side, the plus side. Okay, so what do we know about B right now?
Positive 3 will give us a VA.
So what? Say it again.
Positive 3 is the VA.
So the vertical asymptote, VA, is 3. And this one had a hole, right? Or did it have a hole? I think it had a hole.
Yeah, 1.
Hole at x equals 1. We'll write that down. It might not mean anything, but we'll write it down anyway. It doesn't turn out that the hole, we don't really care about the hole at 1 because we only care about it at 3. What's happening at 3? So it's still important to know, but not for this question. So again, I'm going to write, I'm going to draw a little picture. Make any math as visual as possible to make it easier for yourself. It's a lot easier when you could visualize something than when you can't. So at 3, 1, 2, 3. I know at 3 there's a vertical asymptote. Okay. Okay. For this problem, I could care less what's happening on the left side of the blue dash. I could care less what's happening over here. I don't care. That's the negative side. I only want to know about the right side. So again, I'm going to pick two numbers. I'm going to try to get as close as I can coming from the left side. So I can't plug 3 in because 3 is going to give me 0. It's going to give me undefined. So the closest whole numbers, I think, would be 5 and 4. 5 and 4. That's what I'm going to choose. So 5 first, 4 second. So I'm going to plug them into the original. So I get 1 minus 5 over 5 squared minus 4 times 5 plus 3. Okay. 5 squared is 25. 4 times 5 is 20. 25 minus 20 is 5. Plus 3 is 8. Negative 1/2. Yeah, negative 1/2, yeah, negative 1/2. So at positive 5, it's at negative 1/2. So negative 1/2, let's see, 5 is right there, so negative 1/2. That's the dot right there, bless you. Okay. So it's on the negative side, but doesn't mean it's going to be negative. It could be going up, or it could be going down. We don't know. We don't know that until we plug in the next number that's closer to the blue line. 4. 1 minus 4 over 4 squared minus 4 times 4 plus 3. So we get negative 3, and it's going to be, what is it going to be on the bottom?
3.
3. 16, yep, 3.
So that does that equal
Negative 1, yeah. So let's go make a dot there. So negative 1 is going to be here. So as I'm getting closer, I'm coming from the side, right? As I'm getting closer to the blue line, am I going down or am I going up? Down. So that means this guy is going to be the same thing as the last one. It's not going to change its mind. It's going to go negative infinity. Okay. All right. Yep. What's up?
How do you get negative 4/8?
Oh, you simplify it.
Yeah.
Did I simplify wrong?
No.
So I get negative 4 on top.
No, like, because I got negative 4 over negative 2.
It's 25 subtract 20 plus 3.
Yeah.
So 25
Negative 5.
That's positive.
Plus 3.
Positive 5. Because positive 25 minus 20?
Oh.
This would be positive. Okay. Yeah, check my mistake. I make a lot of mistakes. So if you guys get something else, please, please, please let me know so that we can. Okay. Let's do the next one. So yeah, so it's a one-sided limit. It's always good to know where the discontinuities are. In this case, the vertical asymptote is at -1, right? X equals.
Vertical asymptote always on one side of one, is it always the x-axis is always
The bottom. Yeah, it's always going to be on the bottom.
No, I'm talking about because that you said x is -1 to the left. Is
Yeah.
it always going to be the vertical asymptote like all the other ones too? Like
No, not necessarily. Not necessarily, yeah. Yeah, because that was a great question. Let's say we had gotten a vertical asymptote at -6. It wouldn't matter for this problem, right? So what would you do? You would just plug in -6 in there. If these two guys match, then we got an issue. We can't plug it in, okay? So I said, not necessary, but I draw graphs anytime I'm doing these problems because it helps me visualize, helps me see what's going on. Okay, so we know there's a vertical asymptote at -1. Okay. And we want the limit at -1 from the left side. So we're coming from the left side. So is it going to be going up? Is it be going down? That's what we need to figure out. So okay. So it's at -1, so I'm going to pick -3 first and then -2 second. Okay. So let me plug it into the original, see where I'm at. -3 plus 1 squared. And then -2 plus 1 squared, right? Okay. All right. So let's see. 1 over, let's see, it's going to be -2 squared, which is 4, right? 1/4? So -3, 1/4. Up barely. Next one, 1 over, what is that going to be, -1 squared, which is 1. So this is going to be 1 over 1, which is 1, right? Yeah, so it's going to go up. So -2, 1, make a dot. Yeah, so this one is going up. You can just put infinity. You don't have to put positive infinity because if, any number that doesn't have a sign in front is always just considered to be positive, or you could put positive infinity. If it's negative, put a negative. If it's positive, you don't have to put the positive, but you can if you want.
Is it -3 times -3, 9?
Yeah, but you gotta subtract, you gotta add first. So you get -2 squared, you get -2 and then squared. Okay. All right, last one. So this last one, we didn't know, we don't know anything about it yet. We don't know anything about it, and it's a one-sided limit.
It's
So what should we do first?
plug it in.
There you go, plug it in. When we plug it in, do we get an answer?
Yeah.
Yeah.
You're done. You're done. Yeah, you're done. So when we plug it in, we get 2 squared over 2 squared plus 4, right? So we get 4 over 8, right? You're done. That's your answer. Was there a vertical asymptote? Maybe, maybe not, but it didn't happen at 2. In fact, this guy's not going to have a vertical asymptote at all because there's no way, there's no number I can plug in there that would make it 0. I should say there's no number. There's no real number. There's imaginary numbers. It would have to be an imaginary number to plug it in there to make it 0. Imaginary, so imaginary is when, so watch this. I'll show you, watch. Because I thought, so when you guys first said do this problem, I thought you guys were going to tell me find the vertical asymptote first. It was kind of a trick to see if anyone would say find the vertical. There's nothing wrong with finding the vertical asymptote. You could have done that because we didn't know it because it wasn't on the first side, right? But what happens if I set it equal to 0? So you're going to subtract 4 from both sides, right? So x squared equals -2, right? Or sorry, -4. So you're not going to divide, right? What's the opposite of squared? Square root, right?
Oh, it would be I2.
There you go. It would be plus or minus 2i. If you don't know, if you forget about imaginaries, just ask your calculator. I know you can't use calculators on this question, but ask your calculator that. Your calculator will freak out. It'll say error. Because there are no two numbers that are the same that can make -4. -2 and +2, but those aren't the same. So that's where imaginary comes from. You would get plus or minus 2i. That's imaginary. Well, we don't deal, this class, that's the nice thing about this class. We don't deal with imaginaries. We only deal with real. Okay, so what actually is there. So in Math 3 and Math 2, you start talking about imaginary. In Math 3, you get into more imaginary. This class, we don't care about imaginary. All we want is the real stuff. So there is no asymptote.
Is there a college class that goes more in depth?
Yeah, in college you'll get more into depth in it. There's different types. There's like linear algebra, college algebra. Those algebra classes, you'll get more into all that good stuff. But yeah, in calculus is very narrow. We talk about 3 things: limits, continuity, derivatives, integration. It's very limited. It's not a very big. Algebra is huge. Algebra is so big that you guys start with algebra in 6th grade and you go up to Math 3. That's how long algebra is. Algebra is just literally anytime you see a letter in math, that's algebra. So if there's variables in math, that's algebra. Okay? So there's a little bit of algebra, like we had variables here. There's a little bit of algebra in this class, but we don't deal with that a lot. It's very, like I said, it's very narrow what we deal with. We just go very deep on those. That's the thing. Okay? All right, guys, we got 20 minutes, so let's